Welcome to Episode 9, focusing on the birth of general emergence mechanics, or GEEM, and the three axes of persistence. We have established the local phase structure and introduced global admissibility. Now, the framework requires a language to describe persistence itself. To move from stability to persistence, we acknowledge that local minima and admissibility are necessary but incomplete. The framework needs a way to describe survival, resistance, and recovery. The first axis is depth D, which relates to basin retention, robustness against perturbation, and the difficulty of dislodging a state. It is persistence under stress. The second axis is stiffness K, defined by restoring strength, resistance to deformation, and the rigidity of the pattern. It represents memory under displacement. The third axis is viscosity V, which captures lag, hysteresis, and delayed recovery. It is essentially the memory of disturbance. Persistence is not a single number. Depth without stiffness is incomplete, and stiffness without viscosity is incomplete. Persistence requires retention, resistance, and recovery together. The persistent state can be described in coordinates D, K, V. GEEM begins when persistence is described using these three axes: depth, stiffness, and viscosity. The framework changes here. From modal theory's local structure and GCF's global admissibility, we arrive at GEEM, defined by persistence geometry in the DKV space. Persistence becomes the main language, with depth, stiffness, and viscosity as the three necessary and interwoven axes. This marks the beginning of GEM proper. We are left with a fundamental question. If a system has depth without stiffness, or stiffness without viscosity, is it truly stable, or is it only incomplete? Join us in Episode 10, where we will explore the persistence score and various failure modes.